Hello students, welcome to my channel Arun's Physics Portal. In this lecture, I will be talking about Newton's forward difference formula in interpolation. This topic is useful for BSc and MSc students of physics, mathematics and statistics. The JRF and NET aspirants will also find the topic useful. The complete note of the topic is given here for your convenience. I hope you enjoy going through it. Now let us come to the topic. Newton's forward difference formula is used when the argument for which the corresponding entry is to be calculated lies at the beginning of the data given for the argument. This is given by the formula fx is equal to fa plus u delta fa plus u into v minus 1 upon factorial 2 delta square fa and so on, where x is the value corresponding to which the entry is required. A is the first argument and u is defined as the period of interpolation minus period of origin upon interval of differencing. The last term in equation 1 depends upon the number of entries given. If you are given n plus 1 entries, so that fx can be represented as a polynomial of degree n, then by the fundamental theorem of differences or finite differences, delta to the power n fx will be constant and all higher difference will be 0. This equation 1 is known as the Newton-Gregory formula for forward interpolation. Suppose we have two series of data given. One is for x and the other is for the corresponding height. So we represent the age x, age by x, and the corresponding height by fx. So this is your argument and this is your entry. The age is given at the interval of 1 year, 1 year, 2 year, 3 year and so forth up to 18 years. The corresponding heights are 40 centimeter, 60 centimeter. At the age of 3 years, this is 75 centimeter, and the age of 18 years, this is 1.5 meter. If I have to find out the height of a child at the age of 1 year and 6 months, then because the age lies at the beginning of the data given for age, we use Newton's forward difference formula. If we had to find out the height of the child at the age of 16 years and 6 months, then we had to use Newton's backward difference formula, because the data 16 years and 6 months lies at the end of the series for the age, that is x here. Okay, so now let us come to the example. This is the example 1. Estimate the expectation of life at the age of 16 years by using the following data. किस डेटा से, किस मेथड से निकालना है ये नहीं दिया है, डेटा दिया हुआ है, आपको वैल्यू निकालनी है. So we have here age. The age is simply the argument. Expectation of life, this is your entry. The age is given at the interval of 5 years, 10, 15, 20, 25, 30, 35. So this interval is 5 years. So h is equal to 5. The first argument is 10. So a is 10. So a is 10, h is 5, and x is 16, because this is the argument for which the expectation of life is required to be determined. So we have the formula yx. Yx is nothing but we have written yx for fx. Okay, yx is ya plus u delta ya plus u into u minus 1 1 factorial 2 delta square ya and so on and so forth. Okay, so ya is your fa. Okay, so we have u equal to x minus a upon h. This we have seen. So x is the year of interpolation, a is the year of origin, that is the initial argument, and h is the common interval of differencing. So we find out the first the value of u. So x is 16. Okay, x is 16, a is 10. The initial argument is 10, and the year of differencing x is given at an interval of 5. So this is 16 minus 10 upon 5. So this is 1.2. Now you prepare the difference table. We have different columns here. In the first column, we have the value of different arguments. This is 10, 15, 20, 30, 25, 30, and 35. And the corresponding entries are given here in the second column. 35.4, 32.3, 29.2, 26.0, 23.2, and 20.4. The first forward difference is given here in this column. First forward difference, that means the difference of these two. So this is 32 minus 0.3 minus 35.4. This is minus 3.1. This difference is 29.2 minus 32.3. This is minus 3.1. Then this difference is 26 minus 29.2. So this is minus 3.2. This difference is 23.2 minus 26. This is minus 2.8. And this difference is 20.4 minus 23.2, and this is minus 2.8. So this is the first order forward difference. Now calculate the second order forward difference. What to do? Take the difference of these two. Difference of these two is 0. Okay, because these two are equal. Difference of these two, minus 3.2 minus 3.1. So see here, minus 3.2 minus 3.1. This is minus 3.2 plus 3.1. This is minus 0.1. This is what we have written here. Okay. Similarly, the difference of this 0.4 minus 0.1. So this is 0.4 minus 0.1. So this is 0.4 plus 0.1. This is 0.5. This is we have written here. Okay. Then difference of these two is 0 minus 0.4. This is minus 0.4. Okay. Now take the difference of these two. 0.5 minus of 0.1. So this is 0.5 minus 0.1. So this is 0.5 plus 0.1. This is 0.6. This we have written here. And then this is minus 0.4 minus 0.4 minus this is 0.5. 0.5. So this is minus 0.9. And finally, the difference is minus 0.9 minus 0.6. So this is minus 1.5. This all are written here. Okay. Now this is the way in which it varies in the forward direction. There will be no column beyond this because this column has only one value. And for taking the difference, we must have at least two entries here. So this is only one, so there will be no further difference. Okay, now use the formula and put these values in this order. So this is insert the values. This is 30.5.4 plus 1.2 into minus 3.1 plus 1.2 into 1.2 minus 1 upon factorial 2 into 0 and so on. Go on putting these values and solve it. It gives you the expectation of life at the age of 16 years as 31.7 years. Okay. You have simply to put the values here. This we have taken from the difference table by the red arrow in the table moving in the downward direction. This is forward and this stands for backward. So remember this. Now second example. Given root 5 is 2.236, root 6 is 2.449, root 7 is 2.646 and root 8 is 2.828. Find root over 5.5 by using Newton's forward formula. Here we have y equal to yx equal to root over x. You see here, these are the arguments and this is root over x. So x is 5, 6, 7 and 8. These are given. These are the arguments and these are the entries. Okay, so prepare the difference table. In the first column we have the arguments 5, 6, 7 and 8. In the second column we have the corresponding entries. For 5 this is 2.236, for 6 this is 2.449, for 7 this is 2.646 and for 8 this is 2.828. Now the first order difference. The difference of this and this is 0.213. The difference of 2.646 and 2.449 is 0.197. The difference of 2.828 and 2.646 is 0.182. Next, the second order forward difference. The difference of 0.197 and 0.213 is minus 0.016. The difference of 0.182 and 0.197 is minus 0.015. And third order forward difference is the difference of these two. The difference of these two is minus 0.015 minus 0.016. So this is minus 0.015 plus minus gives you plus here 0.016. So this is 0.001. Okay, this is what we have written here. Now put these values in the Newton's forward difference formula. Okay, put the values here. You put the values here. So y 5.5. You will find the value of root over 5.5. So this is a, the first argument is this. Then this put the go on simply putting the values 0.5 into 0.213 plus 0.5 into 0.5 minus 1 factorial 2 into minus 0.016 plus 0.5 into 0.5 minus 1 into 0.5 minus 2 factorial 3 into 0.001. If you put the values, these values and simplify it, this gives you the value of y 5.5 or this is your root over 5.5. This is root over 5.5 is 2.345. Okay, so this is how we solve the problem. I assume you like this presentation. यदि आपको मेरा यह प्रेजेंटेशन अच्छा लगा हो तो इसे लाइक करें, शेयर करें और मेरे चैनल को सब्सक्राइब करें. So thank you for watching. See you next time with some other topic of interest. Till then, goodbye.